So here we have some true-false questions. First of all, 10 to the x plus 2 equals 9 implies that we can take ln of each term, term by term. Well, this is false. False. You have to first solve for 10 to the x, then and only then take ln. How it's written, how it stands now, it would imply that ln of the left-hand side, which is 10 to the x plus 2, it implies that it's what's written here, ln 10 to the x plus ln of 2, but that is not true, and we cannot simplify a sum that's inside the logarithm like this, so it's false. Next problem asks x cubed plus 1 is an odd function. So in order to see whether something is an odd function or even function, what we do is we replace x by negative x. So this is negative x cubed plus 1, which is negative x cubed plus 1, and this is not equal to the original function, and it's not equal to negative of the original function, because negative of the original function is negative of x cubed plus 1, so it's negative x cubed minus 1. So this function x cubed plus 1 is neither, so it's false. This function is neither even or odd. Neither even nor odd. And we could have known this because a constant is x to the power 0, 0 is even, so you're mixing odd powers of x with even powers of x, and we know that such a mix-up would not produce even or odd function, it's neither. Next question is asking, so if f of 2 is equal to 1, then f inverse of 1 is equal to 2. That's true. If the function has an inverse, it is a true statement, because if f of x equals y, the definition of f inverse is that f inverse of y is equal to x. So whatever is output of f will be input for f inverse, and whatever is input for f is going to be output of f inverse. Next question, f composed g equals g composed f, and that's false. And we have many examples. Anything that you take is basically going to give you a false answer, a counter example. For example, f of x equals x plus 1, and g of x equals 1 over x. Then f composed g is 1 over x plus 1, and g composed f is g of x plus 1, which is 1 over x plus 1. So these are not equal. Next question is also asking about the composition of two functions, so we have to compose. So how do we compose? We first plug x in the nearest function, so that means g. So we plug first into g, and then this number into f. So we have f of whatever g of x is. G of x is e to the x. And when we compute f of e to the x, we are replacing x by e to the x. So I have e to the x squared plus 1. And this is e to the 2x plus 1. So that is true. The next question is asking logarithm base a of x less than 0 if and only if x is between 0 and 1. This is true. And the way to see it is to draw the graph of the logarithm function. The graph of the logarithm function always passes through this point 1, 0. So when is log base ax below x-axis, that's asking when is log base a of x less than 0, i.e. So from the picture we see that it only happens for this interval of x's. So when x is between 0 and 1. And the last question, every exponential function has a y-intercept. That's true. Sometimes it doesn't look like it from your on your calculators. It looks like the exponential function has a asymptote at 0 because maybe it's too far up to see. But it always has a y-intercept. Y-intercept means we plug in x equals 0. So y of 0 is c times e to the 0 time, a times 0. We're replacing x by 0. So this is c to the e to the 0. E to the 0 is 1, so c times 1, which is c. So it always exists.